This video is about mathematical and verbal expressions. An expression is a mathematical phrase. So in math, when you hear the word expression, that just means a mathematical phrase. And if you think about the English language, a phrase is really just a part of a sentence. It's not necessarily a complete thought. It doesn't have to have a beginning or a middle and end. It doesn't have a period at the end, right? It might just be something like after lunch, right? That's not a complete sentence, but it is a phrase. Or maybe she went. Okay, so those are examples of phrases in English. A phrase in math might be something like 4 plus 2. I'm not telling you what it equals. If I put an equals 6 on the end, it might be more like a sentence than a phrase. So a mathematical expression is just a phrase. It might combine some numbers and some symbols, maybe parentheses, maybe addition or subtraction, some numbers, maybe even some variables. 5x, right? That would be an example of a mathematical phrase. It means 5 multiplied by x. You might even just see the number 5, and that's a mathematical phrase as well. You could call that an expression. So an expression is just a mathematical phrase. Expressions may be written in words or symbols. So you might see an expression like the sum of 4 and n, and that is a mathematical phrase. It's written in words, and you want to be responsible for writing that in symbols. So in order to write that in symbols, you need to know that sum means addition. So to write this symbolically, we would write 4 plus n. You could also write n plus 4. That means the same thing because addition is commutative. It works both ways, which is different from the next one. The difference means subtraction. The difference of n and 1 must be written n minus 1. You cannot change the order for subtraction. So you want to go in the exact same order as the sentence is written in. So the difference of n and 1 needs to be written n minus 1, not 1 minus n. The product of 2 and n. Product means multiplication, which sometimes we use that little x to show multiplication. Sometimes you'll see a dot or parentheses. The product of 2 and n, most often you'll see it written with no symbol in between. It just says 2n. And multiplication can be written in the other order. So you could write n times 2 instead. It means the same thing because multiplication is commutative. It works both ways. But quotient, which means division, cannot be written both ways. It has to be written in the same order as the sentence. So the quotient of 7 and n is 7 divided by n. You'll most often see division written with a fraction symbol, though you might sometimes see this division symbol with the 2 dots and the line in between. And you cannot write division upside down. It completely changes the value of the expression. There are many other words that you might see that mean the same things as sum, difference, product, and quotient, so you should become familiar with them. So sum is addition. You might see more than. More than is the same as saying addition. You might see added to. You might see plus. You might see greater. Okay, so those are all words that also mean sum. For difference, which is subtraction, you might see less than. You might see subtracted from. You might see the word minus. Those all mean subtraction. For product, which is multiplication, you might see the word multiplied by. You might see the word times. You might see the word doubled, which specifically means times 2, or tripled, which means times 3, or even halved, which is also multiplication. It means times 1/2, right? And then for quotient, you pretty much will see the word quotient, or maybe the word divided by. There aren't too many other ways to express division in words, all right? And then there are a few special cases. Let's look at those on the next slide here. So some special phrases that you're going to need to know. These are the ones that often throw people off. So the first one is the phrase less than. So if you see the example, which is a little bit smaller written next to it, 4 less than a number p. Now we know it means subtraction, but if you think about the order of that phrase, it's a little bit confusing. We're talking about 4 less than p. So if p was something like 10, then 4 less than it would be 6. And if you think about the order in which we just subtracted, we did the p, which was 10, take away the 4. In order to get 6. So when we write this, we want to make sure that we do it in the correct order, and it's actually not the order that the sentence is written in because of the very meaning of the word less than. So 4 less than a number p is written as p minus 4. So be very, very careful when you see less than. The word quantity, moving on to the next example, is twice the quantity of a number plus 1. Quantity is a key that you need to use parentheses around whatever comes right after it. So the quantity of a number plus 1 means that a number plus 1, the entire quantity of that, is being twiced or multiplied by 2. So when you see the word quantity, think parentheses. So to write twice the quantity of a number plus 1, we want to do twice quantity number plus 1. And it doesn't say what number, so I use the letter n. You can use any variable you want to be a number if it doesn't tell you what number or what variable to use. Next tricky example is percent of. So percent of is multiplication, but you just have to be very careful when you write this. It says 33% of a number. That of does mean multiply. But we're not going to do 33 times the number. We're going to do 33%. And because percent means per 100, 33% is really 33 over 100. So the most common way that you're going to see this written, 33% of a number, 0.33 times the number. Okay, 0.33 is 33 over 100. The next tricky example is half of a number. So of means multiply. Half of a number, you'll most commonly see it written as 1/2 n. Square of. So square is like x squared. It's x equal 2 above it, or 5 squared, which means 5 times 5, right? So if you're asked to write the square of a number, it doesn't tell you what variable to use. I'll keep using n. The square of a number is written as n with a little 2 written as a superscript, and you would read that as n squared. And this one says the square of a number minus 1. And it doesn't say of quantity, so I'm not putting parentheses around the n minus 1. I'm squaring the n, and then I am subtracting 1. Next example is the cube of. It's very similar to the square of, only this time the exponent will be a little 3. So 2 less than the cube of a number. So this has the less than trick in it as well. So first I want to start by writing the cube of the number, and then go 2 less than that. And the next example is the square root of. This is different from the square of, right? This and this are very different expressions. When you square something, you multiply it by itself. When you square root it, you're trying to knock it down to figure out the product of what and what makes that number. So to write the square root of a number, you use this symbol, square root of n. The next one is two equal numbers. So if you have the sum of two equal numbers, and they're not telling us what numbers they are, but I do know that they are the same number, how do I write the sum of two equal numbers? Well, I would just write it as n plus n, which is very different from the next example, which says the sum of two different numbers. Well, how can I show that I'm adding two different numbers together? I would just need to use two different variables. If I put x plus x, I'm implying that that's the same number twice. If I put x plus y, well, then I know that I'm talking about two completely different values, okay? And that is all.